the analysis and design of the problem, how we can go about making the solution. And we started by creating the data element class, the data collection class, and we are in the data collection class now. We looked at the data collection as an array list. We added the set and get, we added the constructor, we added the add method, and in the previous video we created the code that will draw the bar chart. And this is similar to what you all did in the midterm. So what is left here is to draw the pie chart. And the draw pie chart will be similar to the bar chart. Draw pie, in that it will receive a parameter which is a graphics 2D canvas to draw on, and will receive also a parameter which is the width of the component, and another parameter which is the height of the component. So this will be public void drawPie, and it will receive the same parameters, width and height. Okay. I forgot the integer here. And similar to what we did in the previous video, let's think a little bit on how we can go about drawing the pie chart. And I went through this in class before, so let's just spend a few minutes looking at this. So a pie chart is a circle like this, if I can make a good circle. Right? But that circle will be inside a component. So there will be a component in which that pie will appear. Okay, and that component has component width, and it has component height, and that's what we really receive in the in our method here. We have the height and we have the width. In fact, to draw a circle, you need the center of the circle, and you also need the radius of the circle. All right, so this is the radius of the circle. But our pie chart, the data that we have is not a circle. We have length. We have length 1, length 2, length 3. So to draw length 1, length 2, length 3 in a pie chart, we're assuming that if we start from here, then length 1 will probably represent a slice like this. So length 1 is like an arc like that, starting from here and ending here, and this will not really be representing length 1, it will be representing a ratio of length 1 to the total. In other words, it's representing the percentage, because a pie chart does not represent the absolute value, it represents a percentage. So what we will need to do is to create something called the ratio or the percentage, which will be the length 1 divided by the total, and we can call it sum. And when we are time to do the second slice, then we want to look at length 2 and divide it over the sum or the total. So maybe length 2 can be something like this. and this will be an arc that's extending like that, making this angle. And then length 3 will be likewise length 3 divided by the sum, and length 3 as well will represent an arc that is going from one to the other. So it's starting from here and going all the way to this and making this angle. And length 1, though I didn't mention it earlier, length 1 has made that first angle. So if this is an angle, and in a circle, the circle starts from an angle of 0, and the angle increases in that direction, going all the way. This is angle 180. This is angle 270. This is 90. And then finally here, angle 360. So this first angle, it starts from here, from 0, and ends at the angle that represents the ratio or the slice of the first part. The ratio of the first part is the same as the ratio of this angle out of the 36. So the ratio here will be the angle 1 divided by the 36. So if you know the percentage from dividing the length 1 over the total, you can multiply this by the 360, and that will give you the value of the angle number 2. Angle 1. Angle number 2 is very similar. The difference between angle number 2, in addition that we use the ratio from L2, is that angle number 2 starts from where angle number 1 ended. So angle number 1 starts from 0, and then the starting point of angle 2 is the value of angle 1. Then if you go to angle 3, the starting point of angle 3 is angle 2, and angle 3 ratio is the 36 360 multiplied by the L3 divided by the sum. So if you know those angles, then you can go ahead and draw the circle. So we're not really, technically, we are not actually drawing a circle. You probably realize that we are drawing slices. We're drawing an arc. We're drawing an arc for each element in our data collection. So if we have 3 elements, we will draw 3 arcs. If we have 5 elements, we'll draw 5 arcs, and so on and so forth. So to center everything, we need to figure out where we are in the x and y. But let's see what does the method calls for. We have a method called the drawArc, and the drawArc method requires and you can choose drawArc or fillArc. The fillArc needs an x, a y. It needs it needs a start angle and end angle, and it needs the radius, that you have, and it needs a start angle and an end angle. Let me talk a little bit about the arc. So if you start an arc from here, you are starting from a starting angle, drawing the arc until an end angle, and that is your arc. If you're trying to fill that arc, you're filling the area in between, and the arc the fill arc method gets information about the rectangle that contains that arc. So if that's my arc, then this is my x and y points. This is the width of my arc. This is the height of the arc. This is the start angle. And this is the end angle. Okay. So within my frame here, I need to figure out what would the x and y be for each one of those rectangles, for the rectangles that represent each and every one of those arcs. So if I want to maintain the same x and y, the same center, I mean, so the x is the same x as my center, and the y can be any the y will be the center and the radius. So this radius plus, like, if you look at the height, you're leaving like a clearance here, you're leaving the same clearance here, and if you want to center that circle, then that point is the height over 2, the width over 2. So if you leave a clearance here and a clearance here on the circle, then you have the center point, which is the width over 2, height over 2. Center point, the x and y, the x is the same as the center point, so you can say that this is the width, divided by 2, and the y will be that distance, and that distance could be this could be the same distance. So we can say that the y is maybe a constant, let's say 5 or 10, or you can say this is the radius. So we're gonna need to assume the radius also, or you can maybe say if this is the radius of the circle, this is another radius, maybe this is radius over 2, radius over 2. Same thing here, same thing here. So the height will be 3 radius, so the radius will be the width over 2, so the radius will be the width over 3, and the height over 3. So this distance, I can make it as a height over 3, this one height over 3. So I can say this one, let's say we leave the distance height over 3, and or over 4, and then you have the other is this distance, and this, which is the radius of my circle, and the radius of the circle we said is the height over 3. So I'm leaving the same radius area in all of them. Maybe we can make this height over 4. Okay, so let's see how we can go about implementing this. So to draw the pie, I need to calculate a total, this total. So let's implement calculating the total first by creating a method getSum, which calculates the total of the length in the collection. And it returns an integer for the total. So I'll say public integer getSum, and to calculate the total we'll say for, and data element, for each data element E in the elements we'll say, and you probably want to start by sum equals 0, and you will say sum equal sum plus E dot length, E dot get length, right? And then at the end you return sum. Now in the draw method, we'll define the x. So we'll say the x will be the width divided by 2, and define the y, and we'll say that the y equal the height divided by 3, or I'll make it 4 to leave some more room. And then we'll get the sum. So we'll say integer sum equal get sum, and we define the start angle to be 0 and define the end angle, and then loop through the array. So we say for each data element E contained in the elements array, and we'll say first calculate the ratio, get the ratio, and we will have to do something similar to what we did here by rounding up the ratio multiplication of the 360. So I can take it step by step. Can take it step by step, or we can do as we did here and just write it all together. But this time we're calculating an end angle. So we can say that the end angle is the math.round, and we'll need to cast that. Say math.round. And what we are rounding here is the multiplication 360 multiplied by the E dot get length divided by the sum. You see what's happening here? So we'll get the length. Let's say we are at the first element. So this is the length 1. You divide it by the sum and you multiply by 360. That give you the angle, but that give you the angle in double. So you round that to the nearest integer. You cast it down to integer, that give you the end angle. You have the start angle 0, you have the end angle, you have the x, you have the y. Maybe you also need the radius, which will be the height over 3. So we say g2 dot set color, and we say that this is E dot get color and g2 dot fill arc. And maybe I should also do the rectangle as fill rectangle. So I take the first one, the first item, and if you want to know where is this coming from, you can read the documentation, or you can say fill arc and look at the API documentation. I'm trying to get it within my the frame here, and the documentation will tell you what the x is and the y and each one of those parameters are. So we'll say that this is the x, the y, the radius, and then the start angle and the end angle. After you draw the arc, the first arc, we need to assign the end angle to the start angle of the next one, because the loop is going to go back and go to the second element. So in the second element we start from, so we say start angle equal, it's actually the start angle plus the end angle. All right. So that is the drawing of the pie chart. So that completes everything for the data collection. The next step is to create the pie component and the bar component, and these classes will be similar. It extends J component. And you know what, maybe it's better if I do this in another video. Okay.